Okay, number 41, you're given that this is a right triangle, and because this is going from vertex C down to that base, that's an altitude from C down to AB, and you know that 90-degree angles, they're both 90-degree angles on both sides. It furthermore gives you that angle ACB is a right angle. Okay. Tells you that AD is 9 and DB is 3. And it wants some measures you don't have. It wants AC, or CA, I'm going to call that X. It wants CD, which is going to be Y. And it wants CB, which is going to be Z, I guess. I'm just making up some things so I don't have to use complicated variables. Okay, so I'm just going to erase these for right now. We'll remember it's X, Y, Z. And show you how these are actually, when you cut the large triangle into two smaller triangles, the smallest triangle is similar to the medium triangle, and the medium triangle is similar to the whole big large triangle. So they are all similar triangles, and I want to show you why. Let's say that this angle right here, down here at base A, let's just say that that has a measure of little a. Okay? Look at the whole big triangle here. Okay? I don't know what A is. I've got a 90-degree angle here. I've got A here, and I'm just going to call that measure B. I don't know what the measure is, okay? Okay, now undo your focus from the big triangle where your side lengths or where your angles are A, B, and 90. Just remember that A plus B plus 90 is equal to 180. So if you have an A, a B, and a 90, then you've got the full interior measures of a triangle. Now focus your attention here to the small triangle. You will notice, and I'm going to get rid of that mark right there just so you can see it better. We'll just remember that's a right angle down there. You've got a 90 and a B. Well, if you have a 90 and a B, it only requires that you have an A there to make up the rest of the measures of that triangle. So you know that that little portion of angle C has to be A. Okay, so now divert your attention to here, to the medium triangle. And I hope you see that in the medium triangle, that's 90, and you have an A, which means that has to be measure B. And by angle similarity, if you look at these triangles, all of them, the small, the medium, and the large, they all have the same angle measures in there, which means they're all three similar. Now that's important because if you look, for instance, let's compare the medium and the small triangle. If you look at this side right here, it goes from A to 90, and compare it to its own 90 to B. So A to 90 and 90 to B. Okay? So AD to DC. Now look at the small triangle, and let's from A to 90 would be right here, and from D to B would be right there. So you actually could set up, and I accidentally erased that earlier, that should be a 3. You actually can set up a proportion that says 9 is to, and remember that was the value y. 9 compares to y as y compares to 3, and you can solve that. Y squared is equal to 27. If you square root both sides, y is equal to, the square root of 27 is 3 times 9, and I can square root 9 and get a 3. So y is equal to 3 times the square root of 3. So I know that that is 3 square root of 3. Similarly, I can look at, let's go to compare the small triangle to the whole big large triangle. Okay, so looking at that, I'll get red here. Okay, I know that if I go from A to 90, sorry, hold on. If I go from 90 to B, and in the small triangle, compare it to B to A. Okay, now I'm going to compare that same amount in the large triangle. The large triangle, it's here, B, well, 90 to B, And then b to a is all the way across. You can actually create this proportion, and it would be 3 compares to, I don't know what this was, it was z. 3 compares to z in the same way that z compares to 3 plus 9, which is 12. So z squared is equal to 36, square root, and z is equal to 6. Okay, and so you can keep doing that throughout and find x as well. But I want to show you a trick to this, to remembering this, and it's just remembering the order. Okay, if this is the big 90-degree angle, the big one, and this is the altitude, and here are both of the 90-degree angles at the bottom. Okay, the first trick I call heartbeat. Heartbeat will find you that altitude. And I want you to think of a heart monitor that goes beep, beep, and bleeps up and goes down, okay? In this triangle, I had a 3 here and a 9 here, and I've flipped it around, but that's okay. I like it that way because I can see it, but you just have to change your perspective. And this was Y, okay? If you follow the pattern that the heartbeat monitor would follow, which is across, up, down, and across, you would be 3 is to Y as Y is to 9. Y squared is equal to 27, and we've already figured out then Y is 3 squared of 3. Okay? Keep in mind, technically it's plus or minus, but we disregard the minus because you can't have a negative length. All right, that's the first thing. The second thing is this. Imagine there's a little man right here, and he goes out of his house one day, and this is like his little house right there, okay? The two 90-degree angles are his house, okay? He goes out, and he walks to the edge of the mountain, and then he walks up the edge of the mountain, at which point he finds a dragon. Scary! And he goes, ah, and is scared to death. He runs all the way down the mountain, and actually all the way across in front of the mountain, and even past his own house. He's so scared. Okay, so if you imagine that, the proportion, and let me remember which one this was. Let's say this was across from the X. There was a X here, and this was Z. Okay, if you put that into a proportion, it would be 9 is to X. Just follow his path. 9 is to X as X is to, he ran past his house, so 9 plus 3, which is 12. So X squared is equal to 108. Square root. X is equal to the square root of, well, I don't know square root of 108, but 2 times 54 I do know. And then I know that X is equal to, 54 is 6 times 9. And I know that X is equal to 2 times 3 times 3 times 3 times 2. Remember that once you've got it down to its prime factorization, any two of them, 3 times 3 is 9, so the square root is 3, and 2 times 2 there, that's 4, square root of 4 is 2. So X is equal to 3 times 2 is 6, square root of, the only thing left is that 3 right there. So I've got X is 6 square root of 3, Y is 3 square root of 3. All right, repeat that same thing, but let's just say this poor dumb guy does the same thing but goes out the opposite side. 3 is to Z, big scare, as Z is to all the way across past his own house. So that would be 3 is to Z as Z is to 12. Z squared equals 36. Square root both sides. Z is equal to 6. So the answer here is the sum of 3 square root of 3, 6 square root of 3, and 6. Usually we write the rational number first. So 6 plus, and if you have 3 square root of 3 plus 6 square root of 3, treat it like as if it was like 6 plus 3x plus 6x. Okay, you have to add like radicals in the same way that you have to add like terms. In the same way that 3x plus 6x is 9x, 3 square root of 3 plus 6 square root of 3 is 9 square root of 3. So in the end, you get 6 plus 9 square root of 3. And if we go back here, that is A.